You've seen a few examples now of the U-substitution method involving indefinite integrals. What happens if we use U-substitution in a definite integral? Well, the U-substitution part works pretty much the same. The one thing we need to be careful of, though, is that when we change from the variable x into the variable u, we need to change our limits of integration from x values to u values. So let's see how that works. In the following example, we're going to let u be equal to x to the third minus 1. That makes du 3x squared dx. And if we adjust that, 1/3 du is going to be equal to x squared dx. Noticing that I only have an x squared, I don't have 3x squared. So we'll make that adjustment. Now, that will allow me to do the substitution for the integrand and for the differential at the end. But I also need to replace the 0 and the 1 here. Those are x values. They're not u values. So I'll consider the fact that u of 1 is equal to 0 and that u of 0 is equal to negative 1. Now be careful when you do this process, because sometimes the order of these numbers will appear to shift. That is, the upper limit will become smaller than the lower limit. Keep the upper limit as the upper limit, keep the lower limit as the lower limit. Do not change their order. That will affect your integral. So even if the upper one becomes the smaller one, still leave it up there in terms of a u value. If the bottom one becomes the larger one, leave it at the bottom or as the lower limit of integration, because that's where it belongs. So if we go ahead and do this substitution, we're now going to end up with the integral from negative 1 to 0. We're going to have a 1/3 outside that. We're going to have u to the third du. So we do the substitution for the integrand and the differential part exactly the same way we did before, but now we also need to do a substitution on those limits of integration. So if we find an antiderivative here, we're going to have 1/3 times 1/4 times u to the fourth, and we're going to evaluate that from negative 1 to 0. Now we could also do this and then go back into x, that is undo our substitution, and reuse the limits of 0 and 1. This is a lot quicker and a lot neater to do, but you do have that option, and if you're more comfortable returning to x and then using the 0 and 1, you can do that. Just be careful as you go through the process that when you're in u, I recommend you don't write down any limits if that's your goal, to remind you that you do need to go backwards. A common mistake and an easy mistake to make in these types of problems is to substitute the 0 and the 1 in for u values, and you'll get something essentially nonsensical when you do that, because you're using x values as u values, and they're definitely not the same thing. So let's see what we get here. We're going to end up with 1/12 times 0 to the fourth minus 1/12 times negative 1 to the fourth, which is going to be 0 minus 1/12, or just negative 1/12. And that's what we get for our antiderivative. For our definite integral value. You can go ahead and graph the original problem, x squared times x to the third minus 1 to the third power, on your calculator, and use that integral function to check yourself. Remember, it doesn't replace all this work, but it does serve as a check. Make sure that you do indeed get negative 1/12, or about negative 0.083 repeating.